Intel invited me out to Arizona, Fab52 in fact, to take a tour and chat about upcoming Panther Lake laptop CPUs and a new 288-core Xeon 6 Plus CPU. It's not every day that asking questions about things that you notice in your photographic memory gets you a polite reminder warning not to notice that level of detail and ask questions about the things that you see in your mind's eye. Nevertheless, I am fairly confident that rumors of Intel's troubles with 18A are probably greatly exaggerated, and at least one technical execution has been pulled off flawlessly. But other aspects of what I learned are maybe a bit more troubling. Well, depending on a couple aspects about... Let's chat. This is going to be a little bit of a longer chat, but let's chat. Okay, I recently flew to Arizona to spend a few days with Intel and talk to their folks about Panther Lake products, mostly mobile CPUs in other words, and the new features that they're adding, and also learned about some new Xeon 6 Plus CPUs, codenamed Clearwater Forest, featuring 3D stacked dies and what should be a pretty substantial 17% IPC uplift versus their older Sierra Forest counterparts. But it's not Xeon 7, even though it's a new E-core. It's interesting. Now, before we get to that, one of the Panther Lake features they talked about, and the first feature on the list, the first thing we can get out of the way, is the new Integrated Image Signal Processor, ISP. This is aimed at improving video quality on the PCs because quality cameras are selling laptops. This is sort of a curious choice for something that Intel would spend, 30 minutes to 4 hours talking about at a multi-day event, but hey, that's cool. Actually, I think what is happening here, and this was definitely not part of Intel's presentation, this is just me talking here. It's why is this so important? Laptop makers have noticed that because of the forced Windows 11 upgrades, a surprising number of very large customers are electing to deploy Macs instead of new Windows 11 laptops. And so this is driving some alarm, I think, in laptop OEMs. Whoops! A+ business strategy there, Microsoft. Bravo! That's it, really. And that's not really great for the x86 ecosystem, because if you got to ditch your Windows 10 laptop, why not just get a Mac? So Intel, and AMD for that matter, are facing a lot of pressure from system builders and folks building x86 laptops because customers want a good camera, and they want a camera that has good quality. Macs are known for that. I can speculate about the reason. That is my speculation. That was not part of this event. That wasn't anything even Intel remotely hinted at. But they wanted to show off what capabilities they had. Intel wants to improve camera quality without sacrificing power consumption because a lot of business class laptops still have crap tier webcams. And I guess Intel executives have to buy laptops at least, so they want to look good on video conferences and everything else. So there's a ton of improvements. Seventh and a half generation IPU, brand new block diagram, and there's some significant overhauls, at least in the slides that you're seeing. The cameras have access to system memory now because it's a new interface bus. Well, not really new, but they're building on. So frame buffering, temporal, blur reduction, tone mapping, HDR. The demos were very impressive given the image sensors that are in play here. And it'll be nice to see that, people that build laptops have options for including high-quality, low-power cameras in basically every laptop design up and down the stack. It does support IR cameras and other specialty cameras, Windows Hello. It can actually run up to 3 concurrent camera sensors operating at once, 16-megapixel stills. There's a lot of innovative hardware and software that has gone into this, and the team that has done the work is very proud of the work that they have done, and rightfully so, I think. The best demos, however, at the event were from Tom Peterson and his team, of course, and he was very magnanimous with thanking his team. We got to learn a bit more about Intel Xe3 and at least 3 Panther Lake laptop SKUs that are coming, and they were proud of the built-in graphics tiles. There's up to 12 Xe3 compute units on 3 tiles. The CPU layout is also interesting, up to 16 cores. 180 tops, 3 primary SKUs, like I was saying, 8 cores and 2 16 cores. Now, one of the 16 cores has 4 Xe compute units, the other one has 12 for graphics. Is that enough to game on? Maybe. I played on one. Maybe that's the answer to AMD Strix Halo. It's too early to tell, though. With those, you get 12, 20, and 12 PCIe lanes, interestingly. The GPU tile is fabricated on Intel 3, and the CPU tile is fabricated on Intel 18A. 12 Xe tiles? No, they're not tiles. Is that what you call it?
12 Xe cores.
12 Xe cores. Yeah. This is 12 Xe cores. This is what you should expect from a 12 Xe core. Like, this is the floor. It can only get better from here because this doesn't launch until, CES. But and multi-frame generation on Intel's Xe3 platform, playing a modern shooter. This actually comes out at the end of October.
October 21st.
What was the name of the game? Painkiller. So there you go. Painkiller is a game, and it's doing really well. Like, there's you got animation in front of the grass and that kind of thing. You can kind of see multi-frame generation, but this is better than the day zero launch of multi-frame generation that I saw. And so that's very, very impressive from this. And this will be in notebook computers. So, yeah. And we saw during the press event that this was in like the 35 to 40 FPS native configuration, but with multi-frame gen, over 100. So interesting. So the game that they were demoing here is Painkiller. Now, this doesn't come out until October 21st, but this is what they were using as their example for multi-frame generation. The Panther Lake 18A CPU this is running on has 12 of those Xe3 cores. It's running really well. Now, in the stage demo, this was running at 30 to 40 FPS, but the multi-frame generation here, even on the high-speed photography, looked really good. I spent a few minutes playing this and looking into it and sort of poking at it, and again, this was objectively a better experience than I've experienced with multi-frame gen on a 5060 Ti, but not a better experience with multi-frame gen in general. This is a really, really super early look at this. I don't want to read too much into the tea leaves, but I'm really encouraged by what I saw here. I think they could launch Panther Lake tomorrow, at least for Linux laptops. Now, again, the mobile gaming experience that they showed in the demo was pretty solid performance. They were using PresentMon, and we got to see the frame rate. In the in-person demo, I did not get to see the frame rate, but I got high-speed footage. And the high-speed footage looks better than the 5060 Ti with multi-frame generation and resolution scaling. And so that's really good, because multi-frame generation can be good or it can be not good if the GPU can't keep up. And we know under the hood that the Xe3 is running at about 30 to 40 FPS in our AAA title here that's due for release soon. Now, Tom Peterson's other demo was focused on Agentic AI on PCs. And this was one of the most insightful sessions of the event because it wasn't just another AI feature demo. It was a genuine attempt to explain sort of what a useful AI future could look like when the intelligence actually lives on your machine and runs locally using the hardware that you already have. And, laptop hardware is relatively modest hardware. Intel is positioning this as a step forward toward everyday autonomy for the PC, a world where your system can understand your intent, take actions on your behalf, and do so securely and privately without constantly phoning home to the cloud. I think Intel is maybe a little more clued into this than certain operating systems vendors. And so Tom Peterson's demo of that was pretty good. It was an accessible explanation for a wide audience. I hope Intel makes that public someday because it was a good presentation and a good explainer on what Agentic AI is. Peterson framed Agentic AI not as science fiction, but kind of the natural evolution of computing. You can explain what your intent is, and there are small AI models that can help you plan and act locally. And this is, it's not a chatbot. Don't think about a chatbot stuck behind a web browser or a voice assistant limited by, whatever it can do on an internet connection or through that. The AI let you operate, directly on your PC. And depending on what you're running, it'll run on the CPU, the GPU, the NPU in concert to handle different tasks efficiently. It's the kind of vision that helps the press and the industry understand why AI matters beyond, simple benchmark numbers. And so it's nice that that's a wider audience, but there's not really a lot I can get into for our audience. Because, I also got a chance to chat with members of Intel's team working on OpenVINO. This is a rare treat because it wasn't really scheduled or scripted. It's just like, oh, let's chat. It's like, oh, have you told me more than you should? I don't know, it's fine. OpenVINO is Intel's open source toolkit for optimizing and deploying AI models across different types of hardware, CPUs, GPUs, NPUs, even specialized accelerators at the edge. OpenVINO stands for Open Visual Inference and Neural Network Optimization. There we go. And it's essentially the bridge that would allow a software developer to take a trained model from frameworks like, whatever, and make it run efficiently on whatever Intel hardware is available. So you could get a pre-trained model and you don't have to think too much as a developer about where it's running. And whether that's a desktop PC or a laptop or an embedded device, the value of OpenVINO is that it tries to abstract away the low-level complexity of hardware-specific tuning. A developer doesn't have to write separate code paths for each kind of processor or number format, or what kind of hardware acceleration is there for the different types of number formats. OpenVINO is meant to handle that, heavy lifting of quantization, layer fusion, and precision optimization automatically. It can decide which parts of a workload should run on the CPU, which should be offloaded to the GPU, or even if the NPU can get the job done. Because the NPU you can kind of think of more like a fixed function compute device. But depending on what you have, you may have different things that you have to run to achieve the best performance or the best performance per watt if you're on battery. Overall, I like OpenVINO a lot, and the team have been good stewards of the open source model. At times, I think OpenVINO has run faster on AMD hardware than Intel hardware, and I sort of explicitly asked about that, and the reps of the team saw no problem with that. It's like, the response I got was basically, it's like, that's fine. That just means we have more work to do, and it was a healthy spirit of competition there. I thought it was interesting. And the reason I mentioned that is because other offhand remarks from members of the Xeon team were a little more wordying in that respect. And I'm trying to give you some context and some color here, but one of the things I heard directly in the presentation on stage that caught me off guard was something to the effect of maybe Intel does open source something if they're working on something and it helps competitors more than it helps themselves. It's like, ooh, that's kind of a worrying, that wasn't my perception. I mean, guys, I've got two thoughts about this. One, don't flush Intel's sterling reputation in the open source space for no good reason. They're known for being committed to the engineering. There is no need for sour grapes. That mindset completely misunderstands what made Intel relevant again in the modern era of computing. Relevant because all the compute's gone to GPUs, right? The open source ecosystem isn't a charity. It's a force multiplier. Every time that Intel has leaned into open tooling or shared their optimizations or helped shape an open standard, I mean, anything from the Linux kernel to Mesa, Sickle, OpenVINO, One API, Intel has benefited more than they've given away. The contributions ensure developers actually target Intel platforms and that the tools out there are compatible with stuff out of the box. And the broader community builds around that. I mean, you're going to get community momentum from Intel Silicon or x86 Silicon in general. If you got that kind of a protectionist mindset, Intel risks losing not only goodwill, but what influence they have. And that's kind of the second thing here. Intel doesn't realize that there are paid forces stoking the x86 versus x86 division here, with the expectation that that division is going to create opportunity to replace x86 processors with ARM processors or other non-x86 CPUs. Again, the compute's all going to GPUs. Speaking of paid misinformation, those recent articles about Intel 18A yields just don't pass the sniff test. From everything I've seen, even before I did the fab tour, 18A is perfectly fine. But now that I've seen it, I don't know. I don't buy into, the idea that Intel was playing some kind of 4D chess with the press. I like what I saw. We went on a fab tour, and trust me, the security was insanely tight. I can keep a secret, though. I definitely can keep a secret. And I did notice a few things that raised some interesting questions, which I asked. And that's why I later got the polite email encouraging me to, not notice things so specifically. Hey, no cameras or electronics permitted on the tour. That's cool. I'll just take a picture with my brain. I can do that. That's cool. Everyone already knows the certain, there's some pieces in play here. I don't have to spell this out. It doesn't need to be me. It's fine. Oh, ASML up and running. I got to bask in the Fab52. I got to bask in the glow and the low hum of the ASML machine itself, nestled gingerly between the FOUP infrastructure and the automatic reticle handlers. You could tell immediately that Intel has planned for more as well. There's physical space and logistical readiness for additional ASML build-out and scaling right there on the fab floor, which was nice to see and notice, but that's probably the extent of the detail that I'm comfortable giving you. So, just for one rando's impressions, Intel's engineering is looking solid. And even when I notice things that they didn't intend for me to notice, and when it comes to products like Panther Lake and Clearwater Forest, genuinely, it looks like 18A is working at least for Intel. So don't think it's a mechanical problem or an engineering problem. I mean, the Fab tour and the drive around Ocotillo was, the Arizona campus is pretty amazing. It's a square mile. It's easily one of the newest and most advanced manufacturing facilities on planet Earth. So that's pretty exciting. Fab52 broke ground in 2021, 600,000 cubic meters of concrete and 75,000 tons of steel, reinforcement and everything else. Plus then on top of that, 36,000 tons of structural steel. That's moving really fast. One of the jokes is water at a fab in the desert. There's actually a deeper, more interesting story there. Intel says they're water positive in Arizona, and how they do that is the groundwater there is very salty, and so they process it and treat it. And they said that in 2023 they restored about 1.1 billion gallons of water for Arizona. And so this is probably a story and a video on its own. Like maybe that's actually something to look at and go off on a tangent. But before I do that, we need to talk about Xeon. Out of this event, the most sunshine and roses part of it is definitely the Fab, 18A, and the boots on the ground and the engineers. Everybody is optimistic. Everybody is themselves optimistic. The open source comments were a little unexpected, but that's all good. Now, the new Xeon that's coming is Xeon 6 Plus. Clearwater Forest, 288 cores. This is a CPU that drops into existing 6900 series platforms, the one that has 12 memory channels that I've reviewed a bunch. There's a bunch of videos. 6980p, my favorite Xeon in 10 years. Like Panther Lake, it shows off Intel's new packaging capabilities. It stacks new compute tiles on top of the what were 3 compute tiles in Sierra Forest. So here's the base tile architecture. This is the slide. The cores sit on top of this, and those are 18A. And then there's a shared last level cache, 192 megabytes on each of the 3 tiles here. On top of that is the compute tile. 6 modules per tile, 4 cores per module. 24 of the brand new Darkmont E-cores per, compute slice tile thingy here. They have 4 meg of shared L2 cache per module. This all looks great, but things got a bit weird with the massive architectural leaps slide. Sierra Forest, 144 cores to the 288 E-cores Clearwater Forest. But no, Intel has a 288 core Sierra Forest 6900 series processor for that 12 memory channel socket. The shareholders made very clear that playing games with off-roadmap or niche market CPU cores, like CPU products, was not supposed to be a thing anymore. Pat Gelsinger would not have stood for this but I can rent time on a machine in the cloud that has the 288 core Clearwater Forest CPU. I asked about this, and I was told that, that exists, but that's a niche product. Okay, cool. How is the new 288 core less niche than the old 288 core CPU? Not really super amazing answers for that. They did add 2 UPI links, so the new CPUs have 96 PCIe lanes instead of 128 because they have more interconnectivity, which makes sense. It's still socket compatibility, but you'll need a motherboard that does that. But it's still weird, right? I mean, this slide comparing the 8 memory channel platform that launched last year to the 12 memory channel platform that also launched a while ago. It's like, we've got 4 more memory channels. No, you had those memory channels the whole time. Check this out. The microarchitecture power and performance. Up to 1.9 times higher performance versus the 6780E. That's the 144 core Sierra Forest product. Comparing that to the new 288 core part, well, that's twice the cores. 144 cores versus 288. I mean, that's good scaling. Double the cores, almost, but not quite, and double the performance. But again, Intel is pretending the 288 core part doesn't exist. I can just go measure it. It exists. It's real. It also has a pretty decent scaling for certain workloads. Sierra Forest wasn't a bad product. The place in the market where these server parts, like this thing specifically makes the most sense is when you have a vast sea of small containers or small VMs. With the changes in the platform to Clearwater Forest, you should be looking at roughly Skylake performance, maybe a little better. It's an extreme consolidation play. And Intel isn't wrong there with their slides. I mean, that part's accurate. These are E-core Xeons that have been super popular in the telecom industry and a few other niche industries where you want to have a small dedicated container with about 4 to 8 threads. Think like DigitalOcean droplets and stuff like that. So that part of Intel's presentation is great and makes sense. And I agree with it. And I've seen these in the field. The density play, 70 racks consolidated to just 20 racks. That's cool, but something doesn't add up between 17% IPC uplift, but only 1.9x scaling from the 144 core part. So I guess I'm just gonna have to wait to go hands-on and see. Intel was very clear that this is also not Xeon 7, Xeon 6 Plus. That's what they're calling it. And it's coming about a year into the Xeon 6 lifecycle. One aspect of this, and I think that is a great sign, is that Intel can look at all their E-core design stuff and the people that are buying them, how it works and its position in the market, fix some things in the design, and now they can say it's not niche at all about a year later. I mean, that's the upside. But why present it in this weird way? I guess we'll see probably around Q1 of 2026 when they actually launch Clearwater Forest, 288 core. I can't wait to go hands-on with it, but it's such a weird way to present it. So that's it. Easily the best thing from the trip was Fab52 and getting the inside scoop from Fab52 and wandering, off tour and talking to randos. The background chats with Intel insiders, a lot of level 1 text fans. Hello, how's it going? I'm glad to have done the trip and see things for myself. And time will tell if some of my impressions here are correct or not. Because again, remember, at the end of the day, I'm just an internet rando. But I can't notice things, and all the pictures are still in my brain. So, hey, using my brain to remember things. Woo! Now, I had posed questions to Intel about the open source statements that were sort of made offhand, as well as the apparent amnesia for their 288 core Sierra Forest part. And they did actually get back to me right before I was wrapping this video. So first, in the main keynote, they did say that they really want to emphasize their commitment to open source. And that's good. And so they re-emphasized that, and hopefully management will communicate that attitude all the way down the stack. We'll see. Time will tell. And then the 288 core Sierra Forest part, Intel updated the slides and they provided some more reasonable numbers. It looks like about a 17% uplift, so better performance per watt, and 17%, again, we'll have to see. But this is much more reasonable. This is a much more reasonable slide. I don't know why Intel would be embarrassed about this or need to say something versus their 144 core part. They say it's because the 288 core part is not in wide release or it's off roadmap. But again, the new Intel is not the same as the old Intel, and the whole off roadmap thing, like there was a whole, I'm sure that the people in the comments, the Wall Street bros will weigh in on that whole aspect of it. I'm just here to computer janitor. But hey, it's nice to see the comparison, and it's nice to see the gen-on-gen uplift. And this is a little bit projected, but this looks better. I'm Wendell, this is level 1. This is just a polite, fun little ramble. I'm signing out. You can find me in the level 1 forum, so if I missed anything or you have any questions, you can engage below too. I mean, that's fine. All right, I'm signing out and I'll see you there.